welcome you all again to this physics session. I am Dr. Sun Bhatnagar. I am a faculty at Prepaze. So today we'll be continuing our discussion on work power energy. So most probably it will be the last session on that topic. And just before starting, I want to introduce to you Prepaze. Okay, so Prepaze is an online platform where you can find educators like me, which are expert in their field, in their subjects, and you can get knowledge from them at the comfort of your home. Clarify all your doubts. Please do. I will suggest please do check their website and book a free trial class as soon as you can. So let's start today's topic: work, power, energy. Last class, basically, we discussed few things of the energy laws, right? I told you about conservation of energy. What will happen if there is a friction involved, or there is another source from where the energy is being lost? So I told you that it will be like this: the initial energy EI will be equal to the final energy EF plus the energy loss. We discussed an example of an inclined plane where the block was there at top. Initially, when it comes down, there will be friction. Due to friction, or there is some loss. Okay, let's discuss one more question on that. So the question goes like this: you must have all seen skiers, right, which basically slides on the snow. Okay, so this question is related to that only. Suppose this plane or inclined at angle 30 degree. This is, let's say, 200 meters, and let's say there is a skier at the top. Okay, initially at rest, that means V0 is 0. Initially it's not moving. Now the skier basically comes over here and then comes in the flat surface. Comes on the flat surface. These both are frictional. Okay, this 0 is 0.1, let's say, and this is, let's say, 0.1 again. Both have the coefficient of friction. So the question is, where on the horizontal surface, skier will stop. That is, the skier will go from the top initially and it will come and then somewhere, let's say, stops. Okay, that is his velocity again becomes what? Equal to 0. So this is a question you have to find this basically distance. So this is A part, and B part you can do that with the velocity at bottom of incline. At bottom of incline. Mass won't be needed, but it's okay, you can take 70 kgs. Alright, something like this is there. So this is situation. Now, how to proceed with such type of question? Alright, let's do that first. Okay, so if you know this question, please do try it by yourself first. What we'll do the B part first. That is basically they're asking when it reaches over here, when the skier reaches over here at the bottom, what is its velocity? That we need to know. Let me call these, mark the points again. A, this is B, and this is C. So what is happening now when the person, this is something similar to what we did earlier also, right? There is a skier which is at top. Now there is 200 meters given to us. Okay. Now what is the initial energy? The initial energy of the skier, that is energy at A, is what? M into G into H. This is the height H which we need to find out. This is height H. This is H. Alright, this is the height H which we need to find out in our, firstly to find out the MGH, right? So what is this H over here? We can get from the sine theta value. Sine 30 degree is equals to what? Half, which is equals to what? H over 200. So H is what? 100 meters. So the initial energy of the skier at A position is what? MGH. Let me take it M only. G, I will take it G only. H is basically 100. Clear? Right. Now, the skier basically goes on a rough inclined plane. Okay, rough surface. That means there will be some loss of the energy. I told you, because of this, what is an E loss? First of all, we have to calculate. What is E loss? It is friction force into the distance. That is the work done by the friction force. It is a loss in energy. Now, what is friction force? Again, F is what? mu into N, which is mg cos theta. Right. So F is mu mg cos theta. This we discussed last class only. How do we get that? Into D. D is basically how much? 200 meters. Don't take it 100 meters now, because the force is along the incline. We have to take the distance along the incline itself. Alright. So this is the E loss basically. We have to do. So mu value we already know it is 0.1. So it's 0.1 into mg into cos theta, which is basically what? Root 3 by 2 into 200. Alright. So this is 100. This is basically makes it 10. So it is 10 mg times root 3. That is the E loss happening over here. Alright. Now, what is the EF now? EF is basically the final kinetic energy where it reaches at the point B. Right? Because when it reaches at the point B, there is no another energy basically. So we are just talking about the gravitational potential energy and the kinetic energy, right? So at B, it will have only kinetic energy. Only kinetic energy is there. Clear? So let's use this equation. So we have initial energy is m into g into h is 100. EF we need to find out, which is basically half mv square, isn't it? Now what is the loss happened during this journey? It is 10 mg root 3. So m will cancel out first. So we have basically 100 g minus 10 root 3 times g, alright, into 2 equals to v square. Alright, so if you can calculate this, the 2g I can take common. So 100 minus 17.32, because 10 into root 3 is what? Around 17.32. So basically if you do 100 minus 17.32, which is 82.62, then you can just multiply by 20. G you can take 10. So the answer over of this one will be 40.66. So I'll just write the final answer. I think you can just calculate it. This is now the calculation part. The V will be 40.66 meter per second. That is the velocity when the person is at the bottom. Now on the horizontal surface the skier stops. Okay, that is the second part of the question. Let's do that. So I can say that when the person reaches at sea, does it have any energy first of all? Tell us. No, it does not have any energy. Why? Because the velocity is zero, the gravitational potential energy is zero. So whatever the energy the person had initially get lost, everything get lost. How it is getting lost? Because of the friction. So let's do that. So what is happening? EI equals to EF plus E loss. We will use this equation. Now what is EI? EI is what? mgh. What is EF now? EF, now we are doing basically between A and C only, right? So what is EF? It is zero because there is no potential energy and no gravitational potential, no kinetic energy and no potential energy also. So at C, basically, so this is basically at between A to C point. All right. E loss, basically EF is basically this only. What is the E loss now? E loss will be the work done by the friction along the incline and along the plane surface. Let me call it F1 into D plus F2 into D. We already found out F1. Okay, what is F1? It is mu mg. It is 0.1 mu mg into cos theta, sorry, into cos theta, mu mg cos theta into D, which is 200 meters, right? Plus we have F2, which is again 0.1. Now, what is F2 over here? F2 is basically the person standing or skier standing over here on the level surface. On the level surface, N will be equal to mg. We know that. So over here, the F2 will be mu into mg, which is mg I will write only initially, and then we have to find the distance d. So that is mgh is equals to this equation over here. We have to find the distance d over here. All right, that is the question. Let us do that now. mgh. Mgh is what? Basically m into g into 100, and this is what? 0.1. M is what over here? So let it be m only. G cos theta is what? Root 3 by 2. And what is over here? We have 200 plus 0.1. We have basically mg into d. This mg will cancel out first. So what are we left with? Let's see that. So as we have 1 by 10. This cancels from here. This is like goes, and this is 2 tens up. So 10 root 3 g. So g basically cancels out, so we don't have to take g. It's just 10 root 3, and this is what? 100 minus d by 10 plus d by 10. So what is now d? 100 minus 10 root 3. 100 minus 10 root 3 is what? 1.732. So it's multiplied by 10, 17.32. Alright, this is coming into 10. This will be the total distance basically on which the person will travel. So d from this equation turns out to be 82.8 meters. This much meters the person has traveled on the surface before coming to that. So we can just check it further. 17 minus 17.32, 17.32 into 10, right? Yes. So it's to 6.8 meters. That is the horizontal distance traveled by the person. So you can see that how the things are related to each other, and from one quantity you can easily find out the other quantity. So this is basically the energy with considering the energy loss will be used. Please do make sure if you don't get this answer right now, please do try it by yourself. So this is basically about the work power energy, and that one of the few questions of that. There are plenty of more questions obviously we cannot do in such kind of sessions. For those, please do a free trial class and then you can just proceed with the regular classes to understand much more than that. Because there are a lot of concepts to be explained, okay, depending on different questions. This is only the touching the theoretical part mostly. You can see that. To learn more, you need to really practice a lot of questions. So let us move forward then. Now, the next thing which you'll be having is basically power, and we will discuss few questions on that. So what is power? Power is basically, it's the, when we go with the formula, power is work done per unit time, or you can also say it energy per unit time. All right, these are the formulas of power. There is one more form. So these are the main form which you always have to remember. There is one more form which is also quite important. Okay, which goes like this. So now power we know is work done per unit time. What is work? Work done by any force is F into the distance moved d over time. Now d over t is what? It is velocity, F into v. But we can only write d over t when the velocity is constant. Only when v is constant, then only this formula is applicable. Okay, so please do remember it whenever there is a force involved, constant velocity, that terminologies are there. So always remember the basic formula. This is the important. Now, the next thing in this comes is the efficiency. What is efficiency? Now we know that there are obviously every machine which we are using at home, everywhere, right? There are electronic instruments, everything we are using. They have a particular efficiency. No machine in the universe have 100% efficiency. That means whatever the supply power you are going to the machine, what is the return power will be less than that. So efficiency is always less than 1. So how do we define efficiency? Efficiency E is equal to P out over P in. That is how much the output power is this and how much we're inputting the power. Into the 100 will give efficiency percentage. Alright, so this is how we define the efficiency percentage over here. Just make sure this question, this everything is clear. Let's do one question over here. Suppose, let's say there is an overhead tank. This is basically well you can consider, and there is an overhead tank. There is an overhead tank like this, okay, where the water is basically at the bottom and the tank is somewhere over here. Okay, this is the overhead tank. Let's say a motor is operating and the motor is taking the water from here to here at the rate of 1000 liters per minute. Okay, there is a motor which is taking the water from here to here in 1000 liters per minute. Now, the efficiency of this machine is given to us 60%. What you need to calculate, what is the input power? You have to find the input power. How much power is required, input power, not the output, to basically move this water from the bottom to the top, which is at 1000 liters per minute. This is the question. How to solve this? Let's do that. Now, initially, we see that the water is at the bottom, so it will have zero potential energy. And obviously, in both the when the water is taken above, put it inside the overhead tank, its velocity is zero. Initially, its velocity is also zero. So there is no change in the velocity, okay, because it is just kept in that, right? So there is no change in the velocity. Velocity will remain same in both the same cases, and the bottom is at the bottom, and when the water is at the top. Clear? All right. So at the basically what is happening? Only the change in gravitational potential energy is happening. Initially, the gravitational energy is what? Gravitational potential energy is equal to zero. Over here, what is the gravitational potential energy? It is equal to m. M is the mass of water into G into H. That means you need to provide this much amount of energy. The motor has to provide mgh energy to take the water from the bottom to the top. Are you understanding, right? So this is basically P out. What is P out? It is mgh. This is the energy required over the time taken, which is 60 minutes. All right. Now what is mass over here? Okay, we have water basically. We know density equals to mass per unit volume. Mass is basically density into volume. Density of water is what? 1000 kg per meter cube. Volume is what? 1000 liters. You have to convert to meter cube, which is 10 to the power of minus 3 meter cube. 1 liter is 10 to the power of minus 3 meter cube. That means 1000 liters what? Is basically 1 10 to the power of 3. Basically, this cancels out, so it is just one. Basically, volume is what? 1 meter cube. The mass is what? Basically 1000 kg. Right? The mass will become what? 1000 kg. So what is mgh now? 1000 into g, which is 10, into h is what? 100. Over the time is about 60 seconds now. This cancels out from here. Over here, what do we have is basically 1000, 1, 2, 3, 1, 2, 3, 4, 5 over 6. So 1, 2, 3, 4, 5. This is basically the power output we have. Watts. Now, what is power in? We need to find the input power, right? So efficiency is 60%, that is 0.6 power out over power in. What is power in? It is 10,000. So there 1350 10,000 divided by 6. That is power in into. So the power in is basically what? Power out divided by 0.6 divided by 0.6. Whatever the answer of this, you can just calculate and solve it. We're not interested in the final answer, just the concept should be very, very clear. So this is how basically we will be proceeding with the questions like this. We have used the efficiency formula, we have used how much power is required for such questions. That's it class for today, and we'll be meeting in the next session. Okay, we have finished work power energy, and the next session will be continued with momentum. So finally, again, please do check the Prepaze website, book a free trial class, and clarify all your doubts. All right. So hope you like the session. Meet you in the next session. Thank you.